Joining us on behalf of UTPA and the Office for Sustainability, we want to welcome you and thank you for taking the time to come and spend half a day with us. We have a wonderful, wonderful lineup of speakers set up for you, a wonderful workshop. We started these workshops, these educational sessions about 2 years ago, and they have progressed, and we tried to cover as many topics in sustainability as possible. So we do cover a lot within the construction industry, but we also cover in transportation and dining and health, and in recycling and materials and waste management. So there are several topics to cover. We hope that you can join us for some of the others, but if these topics are not within your industry, we understand. We do try, as I mentioned, to cover topics within energy conservation and energy management at least twice a year. So we will have another one coming up next semester, and we hope to have Mr. Abraham and Cesar Cepeda with us for that one. Before I get started, I do want to ask everyone if they could please silence their cell phones. We understand we have many individuals here who are very busy and business owners, so we do ask that if you do need to take a phone call, that you please take it out in the lobby or outside if possible. Again, we will have a couple of breaks. We hope that within the breaks you do network. The intention of our breaks is so that you do network with each other and that you share each other's case scenarios, your case studies. So we are delighted to have you here today. We will begin here shortly, but before I do, I also want to thank the UTPA Office for Sustainability staff. Without their assistance, we could not pull this off. I know many of you have met both Weena Rutledge, she is our program coordinator, and Naomi Keith, who were there just a second ago but now have stepped out. So when you get an opportunity, please do shake their hands and meet with them. They will keep you posted as far as the upcoming workshops and educational series that we have. We here at UTPA Office for Sustainability are striving to become a model and a resource of sustainability for the entire region. This is why we are providing these educational workshops. We do so to educate ourselves on the latest and greatest in terms of products and services that are sustainable, and we invite the general public, we invite our community, because we understand that in order to implement sustainability, we need to do this together. We can't do it just us alone. We do need the support of everyone around us, of our architects, our engineers, our contractors, our city managers and planners, and we need everyone on board, and this is why we provide these educational workshops. So we hope that you enjoy them, and we hope that you will come back again. And I am going to now mention to you there is a sheet that you have on your table. This sheet was provided by Mr. Bob Abraham. He was unable to be here today, but within his presentation he had this little tool. His presentation was going to be on sustainable strategies, and this strategy could be applied whether it's within HVAC, energy, water management. It doesn't matter what program you're trying to implement that's sustainable, you could apply this wonderful tool. So please review it and take a look at it. Again, like I mentioned, we will be bringing him for our next workshop, so he will probably explain all this, but it is pretty much self-explanatory, and we hope that it is something that you can use in the future. I also want to extend a special thank you to our annual donors. Like I mentioned, we have been doing this. This is our second year, and for a second year, BBVA Compass Bank, Innovative Block, and Lax Furniture have been very generous in assisting us. And thanks to their assistance, we're able to bring you these educational workshops and provide the little goodies that you find on your table, like the little notepads and the little bags that carry all your information for these workshops. as well as helping us attend and present at the school district level. We do presentations in K through 12 to help children understand how to live a sustainable lifestyle, as well as many of our libraries and other community events. So thank you very much to BBVA, Compass Bank, Innovative Block, and Lax Furniture. I also want to thank our sponsors for today. Today's workshop is sponsored by Texas AirSystems, Lennox, Advantix Systems, Schneider Electric, and Mechanical Star Systems Incorporated. Thank you very much. I hope you're enjoying the wonderful continental breakfast, and later today we will enjoy a wonderful, wonderful meal. And it is thanks to our sponsors that we're able to do this and provide today's workshop. I also want to mention that we are on Facebook and we have a website, so we ask you to please follow us on Facebook and the website. I have to tell you that I think we're a little bit more current on Facebook than we are on the website. We have a part-time student that helps us upload things to the website, and I know many of you have asked us in the past whether we're going to upload these presentations. This year we have back there in the corner Mr. Kevin Shropshire, who is helping us, assisting us from the Video Services Department in videotaping all these presentations. But it will take us a little bit of time to upload them. So be patient and just follow us and take a look at our website and our Facebook, and you will find those presentations. Our Facebook also announces many events that are happening throughout the region, not just ours here at UTPA, and I think many of them are all relative to what we're trying to do in terms of sustainability. So we hope that you will find it very informative. And we always put little tips of the day or tips of the month that may be very helpful to help you with your sustainable lifestyles and implementing sustainability on a day-to-day basis. We have a couple of events coming up and another workshop. As I mentioned to you, we tried to cover as much as possible in sustainability. So our next workshop is April 4th, and it is going to be on economic development and creating a bike-friendly culture. What we find is that cycling has become something that has increased quite a bit here in our region, but not everyone is actually paying attention to the fact that it is an economic development tool. So we are going to have a workshop coming up to help our city planners and designers, and I hope that some of our civil engineers join us, if we have any here today, join us for this workshop to see how we can assist each other in creating a more bike-friendly culture. We have about $345 million a year that come to the Valley in tourism, and a good portion of it comes from our cycling tourists. So we're going to be talking a little bit about that, and starting to look at complete streets and what it would take to accommodate pedestrians and cyclists so that they could actually assist in the business districts. So for those of you who are structural and civil engineers, it would be great for you to attend and also sit down along with us next to those city planners and city managers to help them understand that you are the professionals that can assist them in actually designing those features. Again, I will put this up a little later so that you can save the date for all these wonderful events. On April 4th, the Economic Development Creating a Bike-Friendly Culture Workshop. April 12th is we're screening a film and reception, Global Lens, The Light Thief. On April 14th, City of Edinburg is having their Earth Day, Arbor Day event, and we will be a part of it. We are partners with them, as well as on April 21st with City of McAllen at Vida Verde. On April 17th, we have our Earth Day baseball game, and we hope that you will join us. It will be the UTPA Bronx against the UT Brownsville Scorpions, and these games are really, really a lot of fun. So if you have never been to a game, you need to come by and attend one of our games. And of course, we are going to be celebrating Earth Day on that day, and we're going to have a couple of individuals and vendors who can help us see what we can possibly do to bring more sustainable practices into our homes. And on April 20th, we're having an environmental health workshop. So again, we hope you can join us for some of these events. And without further ado, I am going to introduce our first speaker. And let's see if I can do this right. There we go. This mouse is so sensitive. I'm going to introduce our first speaker. Mr. Ken Wertz has been in the heating, ventilating, and air conditioning industry for over 14 years. Ken has been a commercial account manager with Texas AirSystems for 3 years and held a similar capacity with the Trane Company for over 10 years. Ken assists industry professionals and end users in the solution of complex problems that arise on a multitude of diverse projects, including dehumidification, cost-effective office building comfort systems, and critical care environments for surgical suites. Ken partners with owners and end users, architects, consulting engineers, contractors, and controls companies to provide unique, energy-efficient, value-added solutions which can be customized to meet specific project requirements. Please help me welcome Mr. Ken Wertz. He's here to present sustainable HVAC systems and practices, managing comfort while reducing total cost of ownership.
All right. First off, I'd like to thank everybody for coming. I am Ken Wertz with Texas AirSystems. I've been involved in this area since about 1998. Worked with the Trane Company for about 10 years. Been with Texas AirSystems for about 3. Basically what my job is, aside from what Mary so kindly read to you, is to basically bring products, services, controls, and solutions to the market. And in the last 10 years, there's really been an exciting amount of developments in the air conditioning systems and the way we go about cooling building and making people comfortable. And I think you're going to hear a lot of the things from some of the other presenters that are here as well. And it's just neat things and neat ways to approach it. And sustainability, there are many definitions for it that you're going to see, and one of which is basically stewardship. And using minimal resources and disturbing the environment in a minimal way so that we leave the earth the same way that we found it. And this has given us an avenue to really spend a lot of money in innovation, coming up with new products, new services, and there's some exciting stuff out there, and it's great to be a part of that. So moving on, I rep many different types of products. I'm also an agent for Johnson Controls in York, so I'm able to put together very large complex systems or very small, very simple type systems. I had many objects that I could choose from today. The 2 things I want to look at, because I didn't want to be here all day and stand in front of you and talk, but I'm going to look at Fanwall Technology and VRF technology. Fanwall today is changing the way that we deliver air. It's both useful in new construction, retrofit applications, and it's a way that we can lower cost both for new systems and existing systems. And then I'm going to switch gears a little bit and look at a total system, which is variable refrigerant flow. We're going to define what it is, when we use it over other systems, and some of the benefits over other systems. It's a tough environment out there today. Energy costs are rising, as judging by how much I paid in gas last week versus how much I paid this week. There's new and changing standards and codes. There's always comfort complaints. That's something we always deal with. Looking out, I recognize a lot of people from different disciplines, and I know that's something we all deal with. Indoor air quality is always important. Green building designs are out there today and gaining more speed as we go forward. But there's also an increase in the total cost of ownership, not just what you pay on the front end, but how much you pay through the life of the building. And that's one of the things that ties into sustainability as we go forward. So first thing I'm going to look at this morning is something called Fanwall Technology. You're always going to have filtration in any air handler unit. You're always going to have a means of cooling, whether it's DX or chill water. What I'm looking at specifically in this application is the fans. I've got a pointer. Instead of having one big fan, I'm going to propose that we look at having a multiple of smaller fans. And we're going to look at some of the advantages of doing this. Okay? What we typically face in an air handler, I would say probably 98+% of what everybody has out there today in an air handler system looks very similar to this. What you have is a hard reflective surface inside of the air handler that rebounds noise all over the place. You have large and heavy single wheel air handlers. That's probably about 98% of what you see out there. And I see the heads nodding. So you've got a big fan wheel and a big motor driven by a belt. In some cases, for some applications, we'll do dual fans and dual motors so you can have a 50% backup in case one fails. They're alluded to the belt drive. Anytime you have a transmission of any type in an air handler, you lose efficiency. They've got a large and heavy motor, so anytime you need to replace it, you need to get multiple people or a gantry out there to move it around. And in having such a big fan wheel and a big motor, it increases the size of your air handler. You need more length. And then depending on your sound application, if you're in a sound sensitive place, you may have to put sound attenuators downstream into ductwork to knock down the sound from this air handler and the fan. So if we could change it, what would we do? Well, we're going to re-engineer the air handler. There's some of the things I alluded to there, and we're going to change that by going to a smaller footprint air handler. We're going to give you back some of your usable space. Multiple fans. We're going to try and attenuate the low frequency sound. With smaller fans, you get a higher tip speed and you get higher noise frequency. You almost eliminate the low sound. Low sound is the toughest to get rid of. So we're going to try and get rid of that. We have softer fan section surfaces, so if you're bouncing sound around in the air handler, they're not going to want to bounce off of this. We're going to go with a higher efficiency fan wheel, and we're going to look at retrofit capabilities of this system. Okay? And here it all is basically in that air handler that I showed earlier. Okay? How do we do this? Well, one of the things that's been exciting in our industry and many industries is that we have a lot of computer tools that make our lives and designs a lot better. We can actually predict what goes on. Computational fluid dynamics, just looking at the pictures there, we can optimize the size of the wheels, all of the components in the wheel, and how the blades are actually set, and we can optimize how these fans work. The important factor in any fan wheel is that basically the shape of the airfoil. It's almost really like an aircraft wing. The throat diameter and the cone geometry, that come in, so the air is coming into the wheel, we can treat that fairly well. The running clearance from the cone where the air comes in to the wheel where it spins off, and the angle of attack of the blade. But most importantly, through computerized tools and selections, we can make the entire fan wheel uniform. Okay? So what do we get? Well, this is the cornerstone of our Fanwall technology. Without going into too much detail on all the other things I talked about, we get a 72% static efficiency. This is a plenum type fan wheel, which are fairly common. We've been using them for about 30 years. But what we do is we take a lot of smaller ones and make them more efficient than the bigger fan wheels tend to be. And I'm going to show that in a little bit. And I tried to make this presentation very neutral. I didn't want to say, okay, CES, they're the ones who do this, they're the ones who pioneer it, which they do. But there are other manufacturers out there who are doing similar things. So it's not like they're the only ones that can do it. Okay? So what we're trying to do is we're also lowering the connected load. These two items right here have the most say in how efficient your air handler actually is. Your wheel and your motor are the two that do that. So we're going to optimize both. Okay? Now this one, I put this slide together, I really kind of misrepresented myself. Right here, if you look up that line, that's 100%. And if you look at the motor efficiency itself, it actually holds pretty well up to about 70% and then starts to tail off as you go down the curve. Okay? What we can do with these motors actually is we can overspeed them. And I'll talk about that here in a little bit, but we can actually go above 100%. We spin them up and go faster at a higher frequency and a higher RPM. But these motors are rated to do that. They are warranted to do that, and we do it all the time. How many people have variable air volume air handlers in their building? In other words, you have a VFD that controls the fan, and as the boxes shut down, your motor slows down. There, I got at least one. Okay, what happens in that scenario is your motor actually slows down, and as you're unloading, you're losing efficiency. Okay. What if we can take all these smaller motors and control them so that they're always operating up here? Well, on part load days, when your boxes are shutting down, we're going to ensure that your motor never gets down in this area right here. Okay. How do we do that? There's several control technologies for fan wall. All of them are kind of hinged on what you want to get out of the system. It can be easy as using one variable speed drive to control the entire fan wall, slow the whole thing down, speed it back up. Okay. All the way down to the most efficient way of doing it, which is taking several small variable frequency drives, no bypass, because you lose your advantage when you start using bypass, and we're actually going to control each fan and optimize it via software. Okay? And that's kind of what this is right here, is we can optimize the efficiency over the entire range of the air handler as we go along by reconfiguring what fans are running and how they're running. Okay, this happens to be a CES specific control panel. Okay, but there are other ways to skin the cat. Okay? Acoustical benefits. One thing about fan wall, and I talked about it earlier, is that there's very little low frequency noise, which is the hardest to attenuate. So by having higher frequency noise, which we typically will have on something like this, it's easier to attenuate inside the air handler. Okay, why is our acoustic important? Well, I stayed at the Hampton Inn last night, and I can tell you I heard that PTAC all night long. Okay? But you wouldn't want to use that in a hotel, but you would want to use it in concert halls, lecture halls, performing arts centers especially, and libraries, where you don't want to hear an air handler banging away up in the ceiling. Okay? Less turbulence equals less noise. Instead of one big fan over here, which you can actually kind of see, the air is reflecting off the side of the air handler over here, versus the fan wall, which all your heavy noise is here in the middle, then you've got a little bit of turbulence on the outside. Okay? There's also a silencer package that is built into the walls of these fan cubes. And I'm going to explain the fan cube in a little bit, but what it does, it basically creates what's called an anechoic or a non-reflective surface or an environment in which these fans operate. So instead of having a lot of breakout noise, these fan cubes will actually attenuate what little noise there is in these. And it's relatively low cost to add it. It's almost like a foam in the inside. Okay? And here's really the beauty behind fan cubes. It gives us greater flexibility in unit dimensions, and this is pretty well illustrated here. Our base fan cube, about a little over 2.5 feet by 2.5 feet. So I can take an air handler and I can stack these up and build it. In this case, for 25,000 CFM, I can build it as a 7 by 9. Well, let's say we're up on the roof and we don't want to see it from the ground. How else can we build it? We can do it like that. Okay, you're somewhat limited by what you can do with the cooling coils as well, but there are varying dimensions that you can use with these, and it's very, very flexible. Okay? And you see, I've got a couple different systems laid out here on the bottom. Here's our fan wall, and we're calling that our base length of 189 inches. So that's actually the length of the fan section as we go down the airstream. This is the one that you see most commonly in almost all air handlers that are out there today. One great big fan wheel. Okay? That one, that's about 47% greater in length. So when you build an air handler, you have to put more metal in to account for that fan section. Here is some we use in applications where you want about 50% redundancy. Not very common, but they're out there. That one is a little bit shorter than this one here. That's a little bit shorter than that. And then going to a vane axial, which is almost like a turbine, that one tends to be a lot longer. Those are very rare. We don't see those a lot out there anymore. Okay? And that's what we get when we look at the air handler. For a representative 42,000 CFM air handler, that's about 308 inches long. Fan wall's 206. So what you gain is 8.5 feet for any mechanical room or mechanical space that you're going to have this air handler in. Okay? Let's talk to system reliability. This is really important from a maintenance standpoint. As you can see, these are direct drive fans with permanently lubricated bearings. So they require no belt changes, there's no belt slippage, and you don't have to go in and hit the Zerk fittings with a grease gun on a periodic level. Okay, there are no shivs, and as a result of us using a lot of smaller motors and smaller fans, there's less weight on the bearings and the shafts, which makes it a lot more reliable. When you have multiple fans like this, you get redundancy out of the box. So if we were running this fan wall right here, and for whatever reason, this motor goes out, well, you can just basically leave that there and take the rest of these fans here, overspeed them, and pick up the load of that motor right there. That's one way to do it with controls. Or the other, let's say you've got, let's see how many fans we got here. Looks like we got 12 fans. Let's call it a 12,000 CFM air handler. One motor fails, you've got 11,000 CFM. Is that okay for now? Could be. Okay. So as a result, instead of that one motor going down and your whole air handler going down, you've got a little time to go run over to your local supply shop, grab a motor, come back and put it on in an emergency situation. Okay. And these use standard off-the-shelf motors that can be bought at your local supply house. You don't have to go to CES or Twin City or anybody to get those. Okay. In the event of a failure, if you have one, we have something here called a zero effect backdraft damper. And there's no motor to it. These basically just sit on the inlet of the fan. And if that motor should fail, rather than recycling the air back around from the other fans, these will actually close under static pressure and form a real tight seal. These don't affect the system in any way. Looking at the airflow pressure drop of a system, the red with no damper, the blue with a damper, it's negligible. In fact, in some cases, there's a little bit of a benefit. Standard industry leakage for any control damper is about 17.5 CFM per square foot at 1 inch. We're at 2. Great thing to have. And there's just a quick slide with a damper and without, showing the acoustic effect of having a damper in there. Once again, very little effect. Okay. Touching more on the ease of maintenance, if you have a time when you actually have to go in and replace the whole fan cube, which is extremely rare, you can just take one out and put one in. You can replace the entire assembly, 2 guys, 30 minutes. So this reduces the amount of downtime there is anytime you can replace something that quickly. Let's talk about that a little bit more. Here's a dual fan unit, okay? And the owners of this unit were planning so that if they lost one, they would have at least 50% capacity. But in the event that they do lose one, they've got this motor here to replace. If the fan wheel dies, then you need to replace the fan wheel as well. To get to this unit, they need a big old crane to get into the middle of the building. Obviously, this is a specific scenario, just happens to be their scenario. So you've got a 2,800-pound motor and a 480-pound fan wheel on this. How many people does it take to carry a 2,800-pound motor? Too many people. Okay? So what we can do with fan wall is build that unit up with all these cubes, and instead of having a crane, we can do it with 1 or 2 maintenance folks to go out there and swap it out. The wheel is 18 pounds. That's pretty light. The motor's a little heavier at 120. And I made this myself. I hope you get a kick out of it. So with Fanwall, if the fan fails at the top of the unit, we can send our guy up there and he can replace the fan. I'm glad you guys like that. I spent a lot of time on that. Okay. Here is basically showing the inlet, and there's the interior of the fan cube. How do you replace these? The easiest way and the best way to do it, you've got 2 bolts on this side, 2 bolts on the other side, and you get our guy that ran down that ladder. He can hold the fan wheel with one hand. Very easy to replace. One thing about these is they're balanced to a very tight grade at the factory. So when you get them, they have almost no, or they don't require any spring isolation, and they have almost no vibration in the system. So as a result, they're very quiet, and you don't have to worry about having any external vibration isolation in the fan wall or the unit itself. Okay? So who's a candidate for Fanwall? Anytime you're looking for energy efficiency, looking for sound, redundancy or reliability, and anytime you want to reduce your cost of equipment and maintenance. These are also great for retrofits. As you can see, here's a guy scratching his head down here trying to figure out how to get this big fan section and a motor into the air handler, whereas we can just take it in on a hand cart, get it in there and just build it up on site. It's also easy to pull all the items in and stage it and have them all sitting in the mechanical room and then just putting them in and bolting them into place. It's that easy to do. You can upgrade your system performance. There's a lot of systems out there that are either oversized, undersized, or there's been changes in the building since the building was originally built that you can actually take care of with Fanwall. You get an improved velocity profile across the coils. Because what happens is this Fanwall, instead of having a big curved volume of air that comes off a fan or in a plenum fan where you have just a pressurized box, these fans actually create a piston of air. So it's very uniform. So you get uniform flow across the coils, uniform flow across the downstream filters if you have final filtration, and they become very efficient as a result. And that's really how everything is rated, is at a uniform airflow. And one thing back on that other slide, if you have sound attenuators downstream, that causes a pressure drop. And every day you're paying at the pump for that pressure drop. So when you put in a fan wall, there's a good chance it's quiet enough you can remove those, and therefore you're not paying for that at your motors every day, that additional static pressure. Energy savings can be 40% or more. Sounds like an infomercial. In these 2 cases here, let me go back. In these 2 cases here, Roosevelt, California saw a significant energy savings by doing 1 vane axial fan. Granted, I don't know too many people that have 139,000 CFM single air handler. In case you do, that's one of the things we can do. The pyramid, there were 2 units done there. I actually know the guys that did this job and know that that's an accurate number. They reduced the amount of energy going into that air handler that they originally had on site. This is just a neat picture I like to show. This is Cardinal Stadium in Phoenix, Arizona. This is the section in the factory as we're building it up. And that's basically just shows all the different fan cubes that are in there. Granted, these are filters. That shows you how big that unit is and how many fan cubes are inside of this unit. Okay? This one I'm going to just touch very quickly on. That unit originally was designed at 325 inches with vane axial fans. To dual fan, we can go down to 199. With Fanwall at 120, saved 10.5 feet. That gave them 10.5 feet of usable space in their mechanical room at Cardinal Stadium. Okay? Okay, I don't want to see a rage of hands, but how many people have an air handler that looks like that, possibly, in their building? And, you know, inside of the air handler looks pretty bad. One of the retrofit opportunities for these, if the walls of the unit are good, we don't have to take the whole unit out. I see the smiles. We don't have to take the unit out, but we can replace coils and fan wall and build it up. That unit was at St. Joseph's Hospital. They're paying 8 cents per kilowatt per energy. Don't know what y'all are paying. I think probably a little bit less than that. But their system amp draw dropped as a result of the replaced coils and fans, and they got a less than a 2-year payback on this system. Okay, I'm going to look at a quick video, and hopefully you'll be able to see it okay. Really, the goals of this, just to kind of look at the reliability of the fan wall system, the decreased maintenance activities as a result, and just note the ease of moving them into space. I'm going to go ahead and hit play and step back. No, I'm not. We'll see what I can do. Hang on.
The existing tower has a fan system that is a single vane axial 140,000 CFM fan that is in a location and was originally installed about 10 years ago that if the fan fails, there is no way to replace the system in an expedient time.
You're always wanting to find that way so that you can either save energy, lower the operating cost of the equipment itself.
When things go down here, if they do go down, we need to have them fixed immediately because a surgery has to have air movement.
The pains are real. The challenges are many. Continuous and uninterrupted airflow is the lifeblood of so many buildings today. And delivering this airflow while balancing performance criteria such as reliability, energy efficiency, sound levels, and space requirements is a challenge many designers face. But these challenges are being addressed with a revolutionary way of moving air. Fanwall Technology by Huntair.
Fanwall Technology is an application of many small fans to do the work of one large fan. In a conventional system where you have one motor, one wheel, when that motor fails, we have 100% failure of the system. When you have two fans in an array, when one fan fails, at best you can get 50 to 60% performance out of the system. With a fan wall array where you have a plurality of fans doing the work that one fan provided to the system, when one fan fails, the other fans pick up 100% performance by taking the load that one fan provided to the system.
Fanwall Technology delivers the system reliability you need. A multiple fan array will help you maximize system uptime by distributing the load once served by a single fan system across an array of fans. And the flexibility of the stackable fan wall cells enables you to match the fan array profile to that of your air tunnel.
The Fanwall product incorporates direct drive fans for a number of different reasons. One, from a reliability standpoint. We do not want to have belts in the airstream that have the highest probability of failure. We incorporate direct drive to eliminate vibration that would be typically associated with belts in the airstream. Instead, we use the direct drive fans with permanently lubricated bearings that never require any maintenance over the entire life of its operation.
Do you have a fan system in need of an upgrade? Is it in an impossible to get to place? A fan wall array could be just the solution you seek.
The space associated with fan wall technology varies on the size of the wheel that's been selected and the size of the motor selected to optimize the array. Typically, we size the fan wall array so that it will easily fit through a standard man door in a building. Not important for what we do in new equipment design, but very important for what we do for retrofit opportunities. We have many applications where fan wall is applied in both vertical applications also, where we're trying to fit within the structures of an existing building or the structure of an air handling unit. There is no limitation to how we can configure a fan wall array to meet the building requirements, CFM and static pressure.
We've seen how a fan wall array can improve air system reliability and make difficult fan upgrades possible. What about its sound?
The acoustics of the fan really are two-part. Number one, we use smaller fan wheels than traditional large types of fans where you might have one or two fans providing all the air for a building. Smaller fans produce an acoustic signature with less low frequency, which gives us a greater opportunity to meet the building requirements without added silencers and so forth. The second half of what we do is we house the fan in what we call the coplanar silencer. And the coplanar silencer is a surround that allows the sound vector as it comes off the wheel to be effectively absorbed. Essentially, the fan spins in what we would call an anechoic space.
Reliability, space savings, and low sound levels all lead to better energy efficiency, which is key in sustainable building designs.
We knew that we could develop a wheel that was very efficient at small diameters. And with that product, we got the efficiency up to and exceeded the efficiency of large wheel diameters. Once we developed that high efficient wheel, we started looking at how we could apply it in different configurations to achieve greater results in the general HVAC industry. In addition, we have controls that optimize and energizes only the number of fans that are required to meet the specific requirements of the building without human interface, all done through the logic of the controls that are integrated into the solution to the customer.
And there you have it. Reliability, energy efficiency, low sound levels, reduced maintenance, real estate savings, and flexible control offerings. Talk to a CES Group representative to learn more about how Fanwall Technology by Huntair can be the right fit for your next application.
Fanwall Technology has been successfully installed throughout the world in the most demanding installations from semiconductor, pharmaceutical, biotech, data centers. When an owner recognizes the importance of his air moving device and recognizes with Fanwall Technology you get reliability, you get energy efficiency, acoustical benefits, you get less real estate requirements to comprise and compress all these components into a smaller footprint, he quickly recognizes that Fanwall Technology is the right fit.
Why put your reputation on the line, and why not use something that's tried and true? So it's nice that the Fanwall did perform above my expectations.
Fanwall gives us the potential to bring in much smaller fans, just stack them up, and you use them as one large fan.
As a whole, the Fanwall system is about probably 10% at least more efficient compared to the vane axial. Given the low sound off the fan walls, we were able to remove the silencers that were installed originally with the vane axial, so we saved some significant static pressure by doing that.
Very good for maintenance, less worry on any one component going out. I very much recommend the fan wall concept.
All right. Great. Just to summarize it up a little bit, Fanwall Technology benefits. We use higher efficiency, small diameter fans instead of a lot of larger ones. Optimize the energy use by doing so. You get a lot of acoustical benefits because the sound properties of these fans. You get a lot of flexibility in how we design the unit. It could be a lot shorter, be real low and real wide, or taller and skinnier. As a result, we get less floor space required for the unit. By its nature, we get a very reliable system, and it's very easy to maintain. We get rid of all the belts and grease in the fittings like you normally do for a normal unit. And all of this rolls into one. We get a lower total cost of ownership, and it is the most economical air handler system available. These are Temptrol specific projects that my office has worked on and that I've worked on personally. I didn't do the DFW airport. As you can see, they did 2 buildings there. AT&T at 530 McCullough in San Antonio, I did work on that one. Think of the other one I did. San Marcos, Texas State University. We did some new units, plus, like I talked about, if you have an existing unit with good walls, we can go ahead and retrofit it using the cubes. And we have several others that are in design currently. Okay. I know it's tough being the first presentation of the morning, and especially putting on a video to where darken the lights for a little bit. But do I have any just general questions on Fanwall that I can answer? Yes, sir.
You mentioned about balancing the factory. Is that the motor and the wheel?
Yes, sir.
Assembly?
Yes, sir.
Replace the motor in the field?
You can replace the motor in the field, and that's a good question. But you don't get that full balancing on the back end. Really, the best thing to do really is when you buy the project, get a replacement. Don't get a replacement fan cube, but have an extra motor and fan wheel on site so that you can take the motor out that failed and the fan wheel, ship it up to Temtrol, replace it with the one that you have as backup, and then they can do the motor and the fan assembly and balance it at the factory, send it back down and put it in stock. That's really the best way to do it. If you're in a pinch and you have to go get a motor off the shelf, then that's how we'd handle it. One in the back, yes sir.
Any installations here in the valley?
In the valley, not yet, no sir.
What's the cost premium, say 3 to 5 tons capacity? Because there's approximately a 2-year payback on that one example.
Right.
Approximately what kind of cost premium are you looking at?
If you were to design a new air handler with a fan wall, you're probably looking at somewhere in the order of $3 per CFM. So it actually looks like a normal air handler is about $1 CFM, typically. So you're almost looking at 3x for the fan wall system, which sounds horrible, okay? But when you actually buy the whole system and put it all together and then run it for 2 years, your cost of ownership, it makes up very, very quickly. So yes, there is a definite front-end premium on doing that. And part of that premium also, the 3x I'm talking about, is we typically see this in custom air handlers. So that $1 a CFM, that's your normal, just a semi-custom type air handler that we see on most jobs. So this actually takes into account a higher quality air handler plus fan wall. That's the comparison that I did. Other questions? Yes, sir.
Do these resolve a initial power spike issue?
I would see that they could if you control them properly. All of these are going to be driven by a variable speed drive, so it's going to have a soft start regardless. It's not like we're going to bang them all out at the same time. And if there is an issue with that, we can stage them on, stage them off, that type of thing too. Yes, sir.
Do you have any configurations where you can actually have a motor replaced while it's still running?
While the unit is still running? Yes, sir.
We have a couple of motors that you cannot turn the air off.
Right. And this can be done, provided that you have a proper way to lock out, tag out that motor's electrical feed so that you can isolate it and then work on the rest of the, or work so that you're not, hot when you work on it. Yes, sir, we can do that.
What's been, when you try to advance this technology versus traditional,
Mm-hmm.
what's been your biggest obstacle in talking to end user customers, and how do you typically overcome that?
Biggest obstacle, there's been a lot of folks, believe it or not, that said, well, there's no belts to change, so I don't want to do that. I don't mind changing belts, which doesn't sound right, but that's the way a lot of people look at it. It's a different technology, so a lot of people don't have a real comfort level with it. And that's the reason why I tried to show the video, is that if you actually look at this on an air handler up and operating, you get a lot clearer picture. It's a lot more understandable, the benefits of it. So some maintenance folks look at it and say, I'm not going to touch it. It's not what I'm used to. Others will look at it and say, man, this is great.
What's been the feedback from MEP engineers and architects on new projects who don't embrace it?
Who don't embrace it? Cost. Yep, cost. And really it's application specific too. If you have, let's say a fine arts center, there sound is going to be critical, then that's going to lend itself more to something like this, because we know that we're going to pay a premium for air handlers regardless, and you're going to have sound attenuation downstream. And now the fan properties of this makes a lot more sense, so we're more willing to do that. Now, if you're talking to an MEP that traditionally is doing schools, daycare centers, things like that, this probably doesn't make a whole lot of sense for it, because you don't need the reliability, you don't need the sound properties, so you can balance your cost, and you don't really need something like that. Other questions? Okay, I'm going to continue on. Need a break in? Okay. No. I'm sorry, I love to talk, so I'll just come up here and start talking about systems all day long. Can we knock just the front lights down just a little bit? Great. Okay, the other system I brought with me today is a variable refrigerant flow system. And this one, there are actually schools out there in the valley that are using this today. I don't know if anybody has any that they're working with, but I'm going to go through just the basics of the system, kind of what it is and how it works, when we use it in lieu of traditional systems, the ease of control of this unit or this system, how you maintain it, and then I'm going to talk a little bit about how many of them are out there. Okay? Very simple type system. It's kind of like a chiller system, an air-cooled chiller system, where you've got a unit outside that's providing your heat rejection, and then via a series of pipes, it goes to all the fan coils inside the building. Okay? But this one uses refrigerant and not chill water as its cooling medium. Okay? These units go up to about 48 tons in water-cooled, 36 in air-cooled, but you can tandem several of them together to get up over 100 tons, 200 tons. And then you have all these multiple units that we'll talk about in a little bit. Okay? How does it work? Well, let's say we put this one condensing unit out here, and then we pipe it to all these different air handlers or fan coils inside the building. You may have a space here that looks like a data center with some racks that isn't cooling all the time, and these may change on and off. And we have a way of dealing with that. Okay? This system wouldn't work good in that application. This is a heat pump, which is much like a heat pump that you'd have in your house. You have one unit on the outside. At your house, you'd only have one fan coil, but here you have multiples, and that unit can either be in heating or it can be in cooling. It's going to operate one way or another. Okay. But here's a much more flexible system. This is called heat recovery. And what you can do is you have this one unit outside, like we had before, but you can have different spaces that have different requirements. Some may be in heating, some may be in cooling. Okay? So if we're in cooling, we can actually remove the heat from here and redistribute it over here. If we run into a situation where everything is then cooling, we're going to use this unit to reject it to the outside and get rid of it. Okay? The advantages over this system, they're very, very efficient. You get significant space savings because you don't have a lot of ductwork and other things to put in. And the electrical draw is less since they're so efficient. The first cost installation, it's more than a normal DX system. We'll talk about that in a bit. But if you look at an air-cooled chiller system where you have water pipe, water treatment, and things like that, this tends to be a lot more efficient. And as a result, you can get lead points from using this type of design. You get chill water type performance. You get great dehumidification because these coil temperatures are around 52 degrees. They wring out a lot of water. And you get precise load matching as you go along. One thing to note, I did not include it here, is that the systems I'm talking about, they require a different unit to handle the outside air. So we'll actually decouple that from this system here. And all the cost things I talk about include that separate cost in them. Okay? Two ways to do it. We have that condensing unit or that heat rejection up here on the roof. That's an air source. Rejects it to the outside. You can actually take these and place them in a mechanical room, duct them in, duct them out. So if you don't have space on the roof or space on the outside, you can do it that way. And then we have water source, where if you have an existing tower on the roof or on grade, we can use that. Ground loops or ponds, not too common down here, and even in Texas where water is an issue, but it can be done. And once again, these locate anywhere on the inside. Sample installation, condensing unit on the roof, small individual fan coils here. We can even use ducted fan coils and wall mounts as well. As you can see, these are real small and almost indetectable in these pictures. These are great for historical buildings. When you can't go in, you can't mess with the walls, break things apart, these are great. You have small refrigerant pipe that you can actually reuse the existing ductwork, run the refrigerant pipe down it, and abandon it in place. Good for retrofits. Once again, leave things in place. And you can actually increase your tonnage, get more cooling out while not changing the electrical service, just because these are so efficient. In new buildings, basically you can save space in the building and in the plenum space, where in the past you had to run ductwork. Now you're just running a thin refrigerant pipe. And you still need some ductwork for that outside air unit, but since it's less, it's going to be a lot smaller. Okay. This is a good slide to representatively show kind of the space savings that you get with VRF systems. Air is not a very efficient medium to transfer heat. Heat in this case, BTUs per hour, 0.48, that's its capacity. It's not very good. So you got to have a big air duct to transfer air. Water pipe is a lot better, has a better number, but it's also wider and heavier. Refrigerant is the most efficient way to do it, and it's a lot smaller representatively. Okay. This is a fur down, so you have ductwork coming through here and then it hits the supply grill and goes out. In this case, we just put a wall unit on the wall. You don't have to worry about doing any fur downs. Okay. This was a 6-story office building analysis in Atlanta, which has a fairly similar climate to here. We're probably a little hotter. They're probably a little more humid. The LG system versus a water source, which we don't see a lot of down here, 18% more efficient. This is a water-cooled screw chiller. So the efficiencies on the water-cooled screws aren't great. Centrifugals are better. But anyway, you see a pretty good savings over this, about a 200-ton system. And then versus packaged rooftops, the multi-V just kills it. Very busy slide. I do not want to bore you with this one, but I'm going to take you down here. Okay, this was Mary Hardin Baylor dorm, and they looked at originally split systems, and then we looked at VRF. As you can see, a regular split system, very inexpensive to put in. You look at that, $260,000 versus $650,000. So the VRV, obviously very expensive when you look at it. The electrical to do all the split systems is $630,000, a lot less electrical with VRV. So your total cost to put in the project is going down right here, even though it went up quite a bit there. Energy savings, they were paying 9 cents a kilowatt hour. At 9 cents a kilowatt hour, VRV is a lot less. And in this case, at Mary Hardin Baylor dorm, they got about less than a 2-year payback. Okay. When do we use them in lieu of traditional systems? There is now a rating system out on VRV systems that everybody will have to publish their data. And so you'll get a pretty good representation of where everybody's operating. Without going into a lot of the AHRI data, some of our units, that's the best case on some of them, 21.8 EER. My air conditioning unit at home, I think it's about a 12 SEER. These get a lot more efficient than DX split systems. For those of you that think in terms of chillers, 550 kilowatt per ton is pretty good for a DX unit. Granted, this is a part load. Okay, well, this kind of ties into sustainability. There are lead points available in using VRV systems exclusively. Energy and atmosphere credits to very efficient systems I talked to before. Material and resources, we can reuse buildings and maintain the perimeters, not disturb a building a whole lot. You can get lead points for that. And the controllability of systems, which I'm going to talk to in a minute, is much easier, and you get great thermal comfort as a result. All right. For those maintenance guys and techs out there who put in split systems, typically when you run a split system, you maybe elevation change, maybe 20 feet. That's kind of getting there. You can go up a little higher than that. Normally 100 feet equivalent length is about the max you want to go. And you can get up into the 150s provided you do an analysis and make sure that everything's piped correctly. We can do a 360-foot height change with these units, from top to bottom or from bottom to top. The branch length is more of a design concern. Max actual piping length, 656 feet. It's about 6 times a normal split system. All told, when you look at the whole system, we can do 3,280 foot of pipe. That's a lot of pipe. But these systems can handle that, and they're designed to handle that. Have all sorts of different fan coil type things. That looks like something you'd see in your house. Floor mounted unit. something that goes up in the ceiling grid. In other words, you can pop out one of these tiles up here and put in a VRV unit. Another pretty picture of lots of units. Controls. I'm doing an 11-story office building in Austin, Texas. It's one block off of the Capitol, so it's off the chill water loop. They're knocking down the old building. They're going to put up a new building. There's no room for cooling towers. There's no room basically to put anything out on grade. Okay, so the solution that the owner and I came up with is we're going to do a VRV system on all floors, and then we're going to have some outside air units spaced every couple of floors to handle the outside air requirement. And one of the biggest points that the owner liked about this system was the controllability, and I'll explain it here. Each fan coil is going to have a T-stat. Or if you have a room like this where you have multiple fan coils in it, you can have one T-stat control up to a couple of units. Okay? This right here is your central control panel. Touch screen, we program it in the field. It comes canned to some degree as well. And then all your interface is through here. You mount that in whatever mechanical room or somebody's office if you like. This control panel plus the programming is about $5,000. Those stats, I think they're about $90 a piece. And then when you wire them in, you've got a central control system for not a lot of money. Comparatively speaking, I am a Johnson Controls rep. Comparatively speaking, if I look at this from that perspective, my Johnson Control system is going to be, who said 7? It's going to be a lot more than that. It's going to be somewhere in the neighborhood of 10x. And this is something that contractors install. They can wire it up for you. There's no need for an external control vendor to do that. And it's also web accessible. So if you're on the internet or on the land somewhere, you can plug in, see what's going on with your unit. A nice, tight, concise system. Okay? How do we maintain them? Simply stated, we wash them down and change filters. That's it. These have permanent cleanable filters in them, so you can pull them out, clean them up, put them back in. Is there much other that goes wrong with these units? Not really. I mean, you have compressors and fans and things like that that could possibly go wrong. But you typically do not have refrigerant leaks. Once again, for the techs out there, we throw this up to about 550 psi for 24-hour pressure test. A lot higher, a lot more than what we typically see with split systems. If there's going to be a leak, we're going to find it when we commission it. Failure rate is very low. Standard warranties, 2-year parts, 6-year compressor. Other options are available. Training. Currently, we have an Austin, Texas training center. We do free owner and contractor training once a quarter. We'll be looking at doing something like that down here as well. Haven't done it yet, we will. And then we have LG has a regional training center in Dallas. It's got entire systems all there. You can go put your hands on it, gauges, do whatever you want with it. Parts, Texas AirSystems, that's my company. We have a parts store in Dallas, Fort Worth, Austin, Houston, San Antonio. Looking again, we'll probably open one down here as well. And then support, plenty of support in Dallas. And then we have statewide support through my offices. Okay, are we going to be the guinea pigs down here? The answer is no. We have multiple installations throughout the country. This is LG specific. Okay, we've got several going in Austin, one up to 310 tons. And then we have 2 systems down here in the valley, IDEA at FAR and at Edinburg. Okay. And that also doesn't account for some of the other manufacturers that are out there. I mean, there's several Daikin systems here in the valley. I'd even bet there's probably a Mitsubishi or 2. Okay, quick summary. I think we've seen what VRF is, single condenser that distributes refrigerant to all different fan coils. When we use it, we want an efficient system at a lower total cost of ownership cost. And how do we maintain it? We maintain, you've seen what the maintenance requirements are for the unit and also how we support it from our standpoint. Okay, so what I've talked about today is rethinking the way that we deliver air in an air handler system by introducing Fanwall. looked at it from new construction and retrofit and how it lowers the total cost of ownership as you go along. And VRF, looked at that as well. Do I have any questions on VRF? Yes, sir.
You've seen water cooling towers, options for these. I just saw AirSystems.
Yes. There are, that condenser, we can either come with a air heat exchanger or we can put a water-cooled heat exchanger in there, so we can do it with existing towers or new towers or ground loop as well. Yep. Other questions? Yes, sir.
How do you transfer heat you were talking about transferring heat between internal spaces without a compressor in line?
Right. What we do is just kind of looking at the system from the room out. Let's say we take a fan coil and we have it up here. And then we have what's called a heat recovery box. It's a box that there's 3 lines that come from the condensing unit. And they pop into this box and there are solenoid valves in there that are going to determine whether we're distributing hot gas to the unit or we're distributing liquid to the unit, which will then go through the expansion device and then cool. Okay? So in the event that we're in heating, we're absorbing heat into that hot gas, okay? And then we're moving it, well, not absorbing heat to hot gas, but basically we're using that box to take the heat from one space, move it to the other. And it's all done by solenoid valves.
Okay.
No compressors in line. Boxes are very quiet, too. You can have a multiple of 4 fan coils hooked up to one heat recovery box. And then you have heat recovery boxes throughout the building, up in the space. Other questions? Okay.
One more.
Oh, I'm sorry.
How do you ensure oil return compressor if it's variable flow?
Right. There's several ways that they can do it. I don't have the engineering portion of it, but there's oil accumulators. Didn't prepare for that one, but no, that's fine. Absolutely, you should ask the question. But I've got your card and I can get back to you on that.
Okay, thank you.
Yep. Yes, sir.
You have outsider, you need to have outsider units for these systems, right?
Definitely.
How do you integrate the control? Can you have the controls for that in the same user interface on a single source? Or
Yes.
you have to have 2 different front ends?
You don't need that. What we'll typically do is we allow the outside air unit vendor to have his own onboard controls to control, if you have a VFD, and also the discharge air temperature. And then to come back to our unit, we'll actually put an interface so we can schedule it on and off. Okay. Any other questions? I realize there's a heck of a responsibility being the #1 guy up in the morning to try and keep you all awake. Hopefully you found this presentation informational. I didn't want to kill you with a lot of detail. Hopefully I didn't do that to some degree. And if you have any questions, I'll be available for a little bit offline, and you also have my contact information. Yes, sir? I can get you a copy of that. Yep. And if you need me to come by, I can do that too. Very good. Thank you all very much.
You do have contact sheets inside your bags for each of the speakers. We are going to take a 15-minute break. Before we do so, I do want to mention, this is something I didn't mention earlier that I do need to bring up. UTPA and the Office for Sustainability are not here to promote, endorse any specific product or service. But we do want you to keep an open mind and understand that everyone around you has different circumstances, different facilities, different needs, different applications. And so we are here to educate ourselves on the different options available. So you will be hearing from 2 more presenters, and they're going to talk about the technologies that they have available. And we encourage you to ask questions. I'm very happy to hear all of you asking questions. It's very important because we all learn from your questions. As I said, everyone has a different circumstance, a different budget, a different type of facility. So these different types of applications, these different types of systems
are something that we need to look into to see which one applies best to our facilities. So please ask questions. Take these breaks, these 15-minute breaks, and engage with the speakers so that you can ask them about more detail about their systems and your specific facility. So thank you once again. We will see you back here in 15 minutes so that we can hear from our next presenter.